Now we've seen before on this channel how to use Pydantic for our data validation in Python applications. And as it says here, it's the most widely used validation library in Python. And it's commonly used with FastAPI, and what we're going to do in this video is build a simple FastAPI application, and we're going to have a React application consuming that API on the front end or the client side. And I want to show how we can use Pydantic for the back-end data modeling and use 𝗁 for our client-side validation, as well as transformations, type coercions, and so on. Now 𝗁 is a popular TypeScript package for validation with static type inference. So this is going to be a simple video showing how to integrate these tools for API requests and responses, and we're going to look at simple nested relationships as we do so. So in summary, we're going to write Pydantic models on the back end, and we're going to write 𝗁 schema objects on the client side. Now before we get started, if you want to support the channel, we have a Ko-fi page linked in the description. Thanks very much to everyone who's contributed, it's much appreciated. And if you want to support the channel, check out the link in the description. Now let's get started. I'm going to open VS Code, where we have a simple backend directory here, and it contains two files. The first one is data.py, and this is a simulation of a database. Let's say we just have a Python list containing some dictionaries with book data. And I think we've got 3 books in this data. What we're going to do is serve those over an API to a React application, and we're going to create Pydantic models for this and 𝗁 objects on the client side to model this data. Now we have a simple main.py file here where we instantiate a FastAPI object, and we're also importing the Pydantic base model. Now I'm going to use the 𝗂 package in order to set up the environment for this project. If you want to know more about 𝗂, check out the video appearing on the screen now that we did before. But what I'm going to do is go into our backend directory, and we're going to use 𝗂 here to initialize a project. So if we run the 𝗂 init command, that's going to create some files in this backend directory. We don't need hello.py, so I'm just going to remove that. And we have a pyproject.toml file that we can use to manage the dependencies for this project. And if you want the highlighting as it is here, then you can install a toml extension, as I've just done for VS Code. Now to add dependencies, we can use 𝗂. So we're going to go back to the terminal here, and let's run the 𝗂 add command. Now we want to add FastAPI along with its standard dependencies here. So on this documentation page that I'll leave a link to below the video, we can copy this here and we can bring it into the 𝗂 add command. And that's going to add this to our environment, and it's also going to create the virtual environment directory, as you can see here on the left hand side. Now 𝗂 is amazing, it's very fast, it's very efficient for installing packages. As you can see, that didn't take long at all. And when you run 𝗂 add, it automatically adds that dependency to the dependencies array in pyproject.toml. Now I want to start now by writing a simple schema for our data. So if we go back to data.py, we have a book object here that contains this data. So we have an ID, a title, year, edition number, and then we have a nested bit of data here for the author of the book. So how can we model this using Pydantic? Let's go back to main.py at the moment, and I'm going to minimize the sidebar and the terminal here, and I'm going to put data.py on the right hand side. So the top level object here is a book object, so we're going to create a class here called book, and that will inherit from the Pydantic base model class. And then we can start defining the fields on the book, for example the ID, which will be an integer, as you can see on the right hand side. We have the title of the book that we're going to set to a string, and I don't know where that integer went there, so I'll add that for the ID. We also have the year, so let's add a field for that, and that's going to be a string as well for now, and the edition is going to be an integer. Now we can add some additional validation with Pydantic here. So for example, what I can do from Pydantic as well as base model, we can import the field object, and for the edition number we can set that equal to a field, and we can have some keyword arguments on that, for example a default, which we should set to 1 for the first edition of a book. And we can also say that this must be greater than or equal to a particular number, and that's going to be 1 because it doesn't make sense to have an addition that's a negative number. So that's just a simple way you can add additional validation on your Pydantic models. And the final piece of data on the right hand side is the author, and that is a nested field here, as you can see. So what we're going to do is set that to another Pydantic model, and we're going to create that above, and that's going to be the author model, and that's responsible for those fields on the author. Again, we have an ID, which is an integer, and we have the name of the author, that is a string. And finally, we have a bio, and let's say this is optional. What we're going to do is set that to a string or none. So it's a union type here, and we're going to default that to none. And that means that the bio is not required, as you can see at the bottom, where it's set to none. So let's close data.py. We now have 2 Pydantic models. This is the top level model for the books, and each book does consist of that nested author data, and the author has these fields here. So we've modeled the data. Let's now create a simple FastAPI endpoint just below this. And we have the app object, and we're going to define a GET request to /API/books. Now we can define the response model here, and what we want to return is a list of the books. So the response model is going to be a list of book objects. And the reason for that, if we go back to data.py, is because this books database that we have in memory is a list of these book objects. So when we convert this response to Pydantic models, we're going to have a list of these books. So we define the response model in the app.get decorator. And the function is going to be very simple. So we're going to have a function called get_books. And that's just going to return the books database that we imported at the top. And that was from the data file. So basically we take this and we're going to return that data as JSON data from this endpoint. Now let's try this out. So if we go back to the terminal here, what we're going to do is run a command with uv. And it's uv run FastAPI. And we're going to run the dev server, and we can pass -- reload to that. And that's going to start the server now. Once that's started on localhost 8000, we can go to this endpoint here. And you can see that when we go to this page, we get the JSON response for that data. So we've taken some data that's defined, and let's say it comes from a database. And what we've done is we've created Pydantic models, and we're returning a list of these models here. And that is all going to be handled by FastAPI and Pydantic. All the serialization of that data to JSON data will be handled from the Pydantic models. And just as an example of the validation that we've got on this addition field, if we set the value of this to a number less than 1, for example, if we go to data.py and set this to -1, when we go back to the page here and refresh the page, we're going to get a server error here. And if we go to the terminal here, we can see what's happened. So we have one validation error here, and it's got the type >= and the field is the addition field. So it tells us about that problem, and we can then fix that. So let's do that just now. So that's how easy it is to add some validation to a field on a Pydantic model class. So now we have a FastAPI endpoint that's returning some JSON data, and that data is validated on the back end with Pydantic. Let's now move on and create a React application to consume that API, and we're going to define front-end validation with Zod. Now, in order to create the React application, we're going to use Vite in this video, and I'll leave a link to this just below the video. And there's two major parts to Vite here. So for example, we have a dev server, and that provides rich feature enhancements over native ES modules. And the second thing that Vite provides is a build command, and that's going to bundle your code using the rollup package in JavaScript. And that is pre-configured to output highly optimized assets for production. Now, if we scroll down here, you can see there's different templates that you can use to create a Vite project. What we're going to use is the React TypeScript template. So in order to do that, what you can do is scaffold a project using the npm create command, and we're going to use Vite latest here. So I'm going to copy this, and let's go to the terminal again. Now I'm in the root directory here, just behind the backend project. So we're going to paste this in, and I'm going to call the project books-frontend. Now when we run this code, we're going to get back some options that we can select on the terminal. First of all, we need to install Vite, but then once we have that, what we can do is select a framework. I'm going to select React, and we can also select TypeScript, and if you don't want to use TypeScript, you can just select JavaScript. Now after that's done, what you can do is cd into this generated directory, so let's do that just now. That's books-frontend, and then we can run the npm install command, and what that's going to do is install the packages in this package.json file. So Vite has some dependencies defined, so for a React template, it's got React and React DOM, as well as some dev dependencies such as ESLint, and of course Vite itself, and the Vite React plugin. Now after it's installed those packages, what we're going to do is go to the front-end directory, and in the source directory, we're going to go to the app.tsx component. That's the root component of the React application. And what I want to do here is just clear this out, so everything within the component, let's remove that, and we have an empty return fragment here that we're going to use in this project. And we can also remove the call to use state here, as well as these assets at the top. So at this point we can get started, and we're going to start by modeling the data using Zod and Zod schemas. So what we need to do on the terminal, just clear that out just now, is run the npm install command, and we're going to install Zod. So let's do that just now. That's going to bring Zod into the application. And then within the source directory, I want to create a new file here, and let's just call this schemas.ts. So for this simple project, we're just going to put all of our Zod schemas in this file. If you have a larger project, you might want to have different files for different schemas and different parts of your application. So I think before we get started, it's worth having a quick look at Zod itself. So let's go to the introduction in the documentation. And again, I'll leave a link to this below the video. Now Zod is a TypeScript first schema declaration and validation library. And the term schema can refer to any data type, for example, a simple string or a complex nested object. And we are going to look at that nested author object in this video. And some of the other benefits of using Zzod, as well as the type safety it provides, are the fact that it's got zero dependencies and it works in Node.js as well as on the client side on all modern browsers. And it's a tiny package as well, only 8 kilobytes minified and zipped, and so on. Now we've already installed Zzod, so we can skip this section here, and let's go to the basic usage section of the documentation. So here's an example of creating a simple string schema. We import the Z object from Zzod, and then we create a schema and we set it equal to the z.string method, and we can then parse objects, for example, by passing in the tuna string here. That will be fine, but if we try and pass something else, for example, a number, that's going to throw a Zzod error. So that's an example with a simple string, but you can also do this with objects, and you can use the z.object function for that. Here we're creating a user that has a single key, and that's the username. And that username within the object has to be a string, and then we can call the user.parse function, pass in some data, and it's going to validate that. And if there's any errors, again, it will throw that Zzod error. And we can also extract the inferred type. So we have a type of user here being defined, and we use the z.infer function and pass that type of user as a generic. We're going to see an example of that in a second. Now let's get started by copying the import here and bringing it into schemas.tst, and we can then define the schemas. So what we're going to do to start with is define one for the author object, and that's going to be called author schema, and we'll use the z.object function here, and we're going to pass an object into that, and this should contain the same keys that we expect to get back from the API, along with any validation that we want to provide for those keys. So the author object had an ID, and that's going to be a z.number. And we're not going to provide any extra validation there, just going to be a number. Then we have the name of the author, that's going to be a string, so we use the z.string function. And finally we had the bio, and if you remember that was an optional field, so let's go back to main.py on the back end. And if we look at the bio, that was a string or it was none, so it's an optional field. How do we represent that in Zzod? We can have this kind of validation, so we can use the string type here, but we can then pass another function into that. So these are chainable, and this function is nullable. If we use the nullable function, it means that the value for this particular key in the object is not required. Now that's the author. We can also define a similar object for the book itself. So let's create another schema here called book schema, and we're going to set that to another object here using the z.object function. And let's define the fields here. Again, we have the ID, which we expect to be a number. We also have the title of the book. That's going to be a string, so we can use z.string here. The year that the book was released, let's say, is going to be a number as well. And this is going to be an example of type coercion, because if we go back to main.py, we can see for the book, the year was defined as a string on the back end. And we can also see that if we look at the API response, the year is a string, but when we define the object on the front end with this schema, we can perform that type coercion by saying that we expect year to be a number, and it's going to convert that string to a number, as we're going to see soon. We also have the edition for the book, and that again was a number, but it had some validation. So we can use the min function here to specify that the minimum number is going to be 1. That matches up with what we had on the Pydantic side, because we have this field here where the default is 1, but importantly the validation here says that this number should be greater than or equal to 1. So this is the way we can represent that using Zzod, by defining a minimum function and passing that number in. And finally we also have the author. That's a key on the book itself, and that can be set to that author schema that we defined just above here. So we set it to that, and that's going to represent our author object. And I've misspelled const here, so let's fix that. So we now have two schemas. We can then export some types at the bottom here. So let's create a type called author, and the value for this is going to come from the z.infer function, and we're going to use the generic syntax in TypeScript here, and it's going to be the type of the author schema. So this type is going to be inferred from the schema that we have here using this z.infer function, and if we copy that to the line below, we can also define a type for our book, and that's going to use the type of the book schema here. Now the purpose of this, if you look at the author schema for example, you can see the values here. This is equal to a Zzod object, and the keys are equal to Zzod types, for example a Zzod number here. But if we go down to the author type that we're exporting now, when we hover over that, we can see that this is better because it contains not only the keys, but also the proper data types that we expect here. So this is how you can take that Zzod schema object and create a type from that very easily by using z.infer. So now that we have two types that we can use, let's go back to app.tsx, And what we're going to do is use a component in here, but we need to create that component. So in the source directory, let's create a new folder called components. And I'm going to create a new React component in here. It's going to be called booklist.tsx. And I'm going to paste some code in here for this component, and then we can explain this code. So what we're doing here is importing the book schema and that type of book that we defined in the schemas.ts file, and we're creating a booklist React component here. Now we're going to store the books that we get back from the FastAPI server inside this state here. So we're using the useState hook in React and providing a default value of an empty array here. And we also have two more pieces of state for loading and for error states. Now in the use effect that's called when the component is first rendered, we're defining this function called fetchBooks, and that is going to call our FastAPI books endpoint. So it uses the fetch function to call that, and it converts the response to JavaScript objects. And then once we have that data from the server, we create a variable here called validated books, and this is where we actually validate the book data that we're getting back from the API. So we're creating an array of these book schema objects, and then we pass the data that we got back here on line 17 into the parse function. And if that works without causing an exception, we can then set the state here using the setBooks function, and we pass the validated books into that, and we can set the error to null. Now we've wrapped this code in a try-catch block because this validated books, this might cause an error if the data is not in the expected format. So we catch that error here, and if the error is an instance of the 𝗁 error, we can then set the error state here using this template string, and we refer to the errors array that is part of that object. This is coming back from 𝗁, and that has a message. Now if we scroll down to the bottom of the use effect, we have the call to that async function there. So that's the use effect hook, and then within the return statement for the book list component, we have a div here with the class name of books container, and what we're doing is we're taking the books that we have in the state, and we're mapping over them, and we're creating a book card. So we need to create this just now, so let's create another component on the left hand side. That's going to be bookcard.tsx, and I'm going to paste a simple component in here. So this card will take the book as a prop, and again we can use this book type here that we created from our 𝗁 schema, and that means that the component knows that this prop here called book is an instance of that book object, and therefore it's got the auto completion in the template here. For example, as you can see here, the book.title. And this is good for the developer experience as well as for the type safety. If we want to refer to a field, we easily have that auto completion now available to us. So this is a simple card component. It's just rendering out some data about the individual book. The last thing we need to do to demonstrate this is go to book list here. And what we're going to do is import that new object. So at the top here, let's bring in the book card. And then for the book list itself, we're going to render that in the app.tsx component. So let's import that at the top, and then within the return statement, we can render the book list. And remember, once that loads the book list, once it's rendered, it's going to call this use effect hook, and it's going to fetch the books from the FastAPI server, validate them using 𝗁, and then display them using the code in this return statement. Now we're going to run both of the servers, so I'm going to create two different terminals here. On the left hand side, we can start the Vite development server with the npm run dev command. And on the right hand side, I'm going to go into the backend directory, and let's start the FastAPI server with the uv run FastAPI dev command. Now of course, FastAPI needs to be running because the front end application that we're building here is fetching that book data from FastAPI, so the server needs to be available to return that data. Now we're going to go to the browser. It's not going to work at the moment, but we're going to fix that in a second. And when we go to this page, we get the message here that we have an error and we failed to fetch the books. Now if we go to the console here, you can see this has been blocked by the 𝗁𝗏s policy. And it turns out that what we need to do is enable 𝗁𝗏s on our FastAPI server. Now I'm going to go to the FastAPI documentation, and if we search for 𝗁𝗏s here, we get a page on this. So cross-origin resource sharing, this refers to situations where a front end is running in a browser, and that has JavaScript code that communicates with a back end, and that back end is in a different origin than the front end. So what we can do if we scroll down is add a piece of code here, and that's a middleware in FastAPI. So let's import the 𝗁𝗏s middleware. If we go back to our main.py file, let's scroll to the top, and we can import the 𝗁𝗏s middleware. Now when you define the app object here, you can add middleware using the add middleware method. So app.add middleware, and what we can do here is add the 𝗁𝗏s middleware. If we go back to the documentation, we can see some examples of what we can add. So we define the 𝗁𝗏s middleware, and we can pass allow origins, allow credentials, methods, headers, and so on. We're going to copy these, and I'm going to paste them into this. And the origins that we want to allow to perform a cross-origin request, I'm going to define these as a list and hard code them in. So what we're going to do is define http://localhost, and it's coming from port 5173. That's where the React application is running. So that's the only origin we want to allow to perform these cross-origin requests. Now this is a best practice. You shouldn't open your entire server to cross-origin requests. Instead, you should be careful and only allow a certain number of origins that you can control or you know about to send these requests. So let's try this again. We're going to go back to the browser here and refresh the page. And we're getting an error now that we have a validation error, expected number and received a string. Now if we go back to the schemas.ts file, I think this is for the year field here that we have. So we defined that as a number, but it's actually coming back as a string. So let's try this again. If we go back to the application, we now get the list of different books along with the data for the author. Now we can style this a little bit better by going to app.css. And if I go to the bottom, what I'm going to do is just paste in some styles that I've defined. And we have a book card class here for each book on the page. Now if we save this after adding some border, margin, bottom and padding, let's go back to the page and you can see that looks, well, it looks a little bit better, but you wouldn't want to deploy this. But at least we can now clearly see each individual book. Now if we have an error, for example, if we go back to schemas.py and change this back to a number, we're just going to get this error appearing on the page. Of course, you could handle that better. But the important point is that Zzod is validating the data that's coming back from the back end, and if there's any problems, you can then respond to that accordingly. Now, I really want this year to be a number, but currently this is causing an error, so let's change it back to a string for now. And the fact that it is a string might cause a problem. Now, here's an example of that. If we go back to the book card, where we render out the year, let's say we wanted to add 1 to that for whatever reason. If we save that and go back to the page, you can see that actually adds the number 1 to the string. So instead of adding 1 numerically, it just concatenates 1 to the string. So what we can do is actually do a data transformation. So it turns out that Zzod, as well as validating data, can also transform it. And that means that it can handle cases where the data coming back from your API has a format that's different from what your user interface needs. So let's see an example here. After we parse this as a string, we can then call another method that's chained onto that, and that's the .transform method. So this is going to transform data after it's parsed. So for example, here we can take the string that we get back from z.string, and we can then call the JavaScript parseInt function and pass that string into the function. Now hopefully that's going to work. So if we go back to our application, you can see we now get the year 1985 here. If we go back to our book card here and remove the +1, it's going to show 1984. The important point being that this is now working as expected because this is a numerical value. So again, when you're passing that data from your API, not only can you specify the types and also some validation logic, but you can also perform transformations of that data from one type to another. So this has been an example of how to use a FastAPI application with Pydantic for your data modeling, and how to create that API and consume that using a React application with Zzod providing the schema validation on the front end. And that has many benefits, so let's just dive into those to finish the video. Now you might be wondering why you have this validation in 2 places if you already have the Pydantic models on the back end. It turns out that having Zzod schemas on the front end alongside those Pydantic models has some important benefits. Now we saw some of them earlier on. For example, in our React components, we get this type hinting here, this type completion. And I say type completion, I should be saying code completion here. So we have a book object and we've given it the type of book from our Zzod schema. And because it's got that type, our editor, for example, VS Code, knows what properties should be on the book. So we get that completion available to us. So this is a good developer experience. It can help us when we are struggling to remember the names of properties, for example, on the different objects that we have. And Zzod provides runtime type safety as well. So what does this mean? Well, TypeScript can perform the compile time type checking, but our API responses are still untyped at runtime. So Zzod is going to validate the actual shape of the data when it arrives from our backend APIs, and that's going to catch unexpected data structures that TypeScript alone might not catch during execution. And Zzod also provides better error handling. We haven't really dived into that too much in this video, but basically if your API does return malformed data, you can catch that immediately at the data boundary. And of course, we also saw that Zzod can transform data as it validates it. So that gives you flexibility when your data needs to be transformed from one shape to another. And a couple of final benefits just to finish the video. If we go to schemas.py, in my experience when I've developed React or Vue.js applications that consume API data, it's always very good to have this contract defined on the front end where you know exactly what should be received or what should be sent to the API, and you have that clearly defined, and that means there's no ambiguity about what kind of data is coming back from the API or being sent to the API. Instead, it's all very clearly defined, and it also helps to catch API changes that might break the front end as well. And the final thing this can provide is some benefits for testing. You can mock data more easily when you have these explicit schemas available. So that's been a dive into FastAPI and Pydantic on the back end, and React, TypeScript and Zod on the front end. We've seen how to validate that data that's coming from our API into the application. We do that by defining these schema objects, and these tell us the shape of the data as well as the data types, and also some transformations and validation that we might want to provide on that data. So thanks for watching. This has been a bit different for the channel, but if you've enjoyed the content, give it a thumbs up on YouTube and subscribe for more of this content. If you have any suggestions as well for similar content you'd like to see along these lines, let me know in the comments. Thanks again for watching, and we'll see you soon.